Today we are working with integers and absolute value. Our essential question for today is what are integers and absolute values and how can you use them? Our goals for today are to define the absolute value of a number, find the absolute values of numbers, and then solve real-life problems. First off, we need to know about different kinds of numbers because we have many different kinds of numbers. Now, the types of numbers that we are going to be working with throughout the course of this year are varied. Now, the ones that we are most familiar with right now are the natural numbers, the whole numbers, and maybe the integers. Now, we do know what rational numbers are, but we'll get into that a little bit more later on, and we do have some kind of intuition about irrational numbers, but we're all going to worry about that a little bit later. And all of those fall under the category of real numbers. Now, when we're talking about natural numbers are sometimes known as counting numbers. These are the numbers that traditionally we use to count with. Like when we're going to go play a game of hide and go seek, we usually start with 1, 2, 3, 4, and so on and so on. We don't generally start with 0. So these are the numbers that come naturally to us. Then, including all of the natural numbers, we move up a step from natural to whole. And what we're going to see here is the difference between whole numbers and natural numbers is we're just going to be adding in this 0. When we add in that 0, we still have all of these natural numbers, but now all of them together is called the whole numbers. So while 1, 2, and 3 are still natural numbers, they are also whole numbers. But if we include 0 in that set of numbers, we're referring to the group of whole numbers. So if I'm giving you a list of numbers and I say 0, 1, 2, 3, you know we're talking about the whole numbers because we included 0. Okay, then we have our integers. Now integers may be a little bit new to you. They probably aren't though. Okay, our integers are going to be including all of our natural numbers, the 0, which means all of our whole numbers, and then it's also going to include all of the opposites of our whole numbers. So we have -1, -2, -3, -4. It's got all of those numbers as well as these numbers down here. So our integers are all of the positive numbers, all of the negative numbers, and 0. Okay. Now those are the big ones that we want to talk about right now. Now, a little bit later on, we'll be talking about rational numbers, which includes repeating decimals, it includes fractions, it includes decimals that come to an end. And later we'll talk about irrational numbers, which are decimals that have no end and have no pattern, like pi, 3.14, 159, etc., etc., etc. There's no pattern to it, and it never comes to an end. And they all fall under the umbrella term of real numbers. Now we're also going to be talking about having letters in math, and when we're usually talking about letters in math, we're going to be referring to them as variables. Now a letter or symbol that represents an unknown number, or in the case of definitions, all possible inputs, are variables. Now don't let that scare you off. Variables are very easy to understand. Okay, they just represent an unknown number. We're trying to figure out something plus 2 is equal to 5. Well, we don't know what that something is, so we're going to try and say, okay, well, what plus 2 is equal to 5? Well, I know that I can plug in a 3 for that number right there, so I know that x plus 2 is equal to 5, so I know now that that unknown number before takes on the value of 3, okay? But it can change from equation to equation. So x, or our variable, represents an unknown number that we can then figure out what that number is. Or if we're talking about definitions, that number can represent any number we plug into there, which makes it true. Okay, so just a darn minute, yesterday said x equals 2. Well, x is going to equal lots and lots of different things. It's okay. Okay, some common variables that we're going to be using are x, y, z, a, b, c, beta, theta, epsilon, and mu, and there's a whole heck of a lot more. So we're going to be worried primarily right now about x, y, and z, and some other letters of the alphabet. So we're talking about absolute values, okay? The absolute value of an integer is the distance between the number and 0 on a number line. The absolute value of a number a is written as absolute value of a. Okay, Now here we don't know what a is, which makes a a variable. And since we're talking about this in terms of a definition, a can be any number. Okay, so if I say, okay, well, let's let a equal -4. Okay, well, then we're looking at the absolute value of -4. Okay, now by the definition of an absolute value is the distance between the number and 0 on a number line. Okay, now we're going to be looking here, we're going to see that this is -4 right here, and we're going to see how far away this -4 is from 0. So we can count over and see 1, 2, 3, 4. Since it's 4 units away from 0, that means it's a distance of 4. So the absolute value of -4 is equal to 4. The absolute value of -4 is equal to 4. Just like when we're looking at +4, it is still 1, 2, 3, 4 steps away from 0, which means the absolute value of 4 is equal to 4. So when we're talking about distances, distances are going to be positive numbers. Okay, you can't have a negative distance. So as we're going through this, we're going to be using number lines. We're going to be looking at how we can figure out how far something is from 0, because that's what this absolute value sign means. It means we're looking for how far something is from 0. Okay. Now remember, when you're making a number line, traditionally we're going to have the negative numbers on the left and the positive numbers on the right. We're going from least to greatest. Okay. And we're going to put the numbers on bottom. Okay. So we can put our steps on top. Now when you write the notation for absolute values, it means to take the absolute value of the number inside of the symbols. Okay, so we have our absolute value lines here, and it's telling us to take the absolute value of what is on the inside of that piece. We don't take the absolute value of everything, we just take the absolute value of what's on the inside. Okay, so let's work through an example here. So we're going to be finding the absolute value of a positive number. So we want to find the absolute value of 2. So we're going to say, okay, we need to first find 2 on the number line. So we're going to graph that right here. We have our number line right here. We're saying, okay, this is the number 2. Now we want to find the absolute value of 2. So we're finding the absolute value of the number 2. Now we know that the absolute value means the distance it is from 0. So we need to find how many steps it is from 0. So that's 1, 2 away from 0. So that means our absolute value of 2, right? Absolute value of 2, not 121, is equal to +2. Since the distance between 2 and 0 is 2, that means the absolute value of 2 is equal to 2. Okay, let's go through one more extra example here. Okay, you can pause the video here and try this one on your own first if you would like to see if you got it right. Okay, so what we're going to do is we're going to find the absolute value of a positive number. So to do that, we need to find the absolute value of 6. So first things first, we have to come down here and we have to graph the number 6 on our number line. So we're going to say, okay, well, I know the number 6 is right here. Okay, so that means I'm going to find the absolute value of 6. Now when I'm finding the absolute value of 6, that means I'm going to be finding how far away that number inside of those absolute value signs is away from 0. So I'm going to be counting how far away it is from 0, and I can see that that's 1, 2, 3, 4, 5, 6 steps away from 0. So the absolute value of 6 is equal to 6 because it is 6 steps away from 0. It's how far away 6 is from 0. Now, for example number 2 here, we're going to be finding the absolute value of a negative number. Now, it's very similar to how we're going to be finding the absolute value of a positive number. First, we're going to find the number -3 on our number line. Okay, we're going to put that little point right there. We're going to say, okay, here is -3. Then we're going to find the absolute value of -3. And we know that the absolute value is how far this number is away from 0. So we're going to take this and we're going to see how many steps away it is from 0. And we can see, oh, that is 3 away from 0, so the absolute value of negative 3 is 3. So the distance between negative 3 and 0 is 3, which means that the absolute value of negative 3 is 3. So what you should notice here is that we are now figuring out that when we have an absolute value sign, okay, of a negative number, it's going to end up being a positive number. And when we have the absolute value of a positive number, it is still a positive number. Okay, so because we can't have negative distances, we can't have negatives as our answers to absolute values, because we're finding the distance, some number inside of that absolute value sign is from 0. So our absolute values will always be positive. So here for an extra example, go ahead and pause the video here if you want to try this one on your own first. Okay, but we're going to be finding the absolute value of negative numbers. So again, our first step here is to find the value or the number location of negative 7 on our number line. So we're going to be looking down here, we'll say, okay, well, negative 7 is over here. Okay, that's where negative 7 is. So if I'm going to find the absolute value of negative 7, then I know that it's going to be how many steps away from 0 this number is. The distance between negative 7 and 0. So I can count my steps and say that's 1, 2, 3, 4, 5, 6, 7 steps away from 0. So the absolute value of negative 7 is positive 7. I want you to go ahead and try these ones on your own. If you need to use a number line, absolutely go ahead and do that. Go ahead and pause the video here, and as soon as you are done, unpause the video and work through these solutions with me. So as we're finding the absolute value of 7, we know that it's going to be equal to positive 7, because 7 is 7 steps away from 0. Now as we look at number 2, when we're finding the absolute value of negative 1, the absolute value of negative 1 is going to be equal to 1, because that negative 1 is still 1 step away from 0. Okay. Now as we look at the absolute value of negative 5, that's going to be equal to 5, because that negative 5 is still only 5 steps away from 0. We go from 0 to negative 1 to negative 2 to negative 3 to negative 4 to negative 5. And then lastly, we have here the absolute value of positive 14, which is going to be equal to positive 14, because it's 14 steps away from 0. That's how far, that's that distance that 14 is from 0. Okay, so as we look at example number 3, we're now going to be looking at comparing values. Now when we're comparing values, we're going to be using some inequality symbols. Now these symbols should be fairly familiar to you. We have this little arrow here pointing to the left when we are talking about less than, which means it's smaller than or it's below. We're talking about this arrow pointing to the right when it's greater than, it's more than, it's above that number. Okay, we're talking about this equal sign when it's equal to or it has the same value as. Okay, so we can use number lines to compare and order integers. Number lines to the left are less than, numbers to the right. Numbers to the right are greater than numbers to the left. Okay, so if we graph 1 on the number line, it would go right here. Now we got to ask ourselves, where would this absolute value of negative 4 go? Well, that absolute value of negative 4, well, what is that equal to? Well, we say, okay, absolute value of negative 4 has to be equal to 4. Okay, because it's going to be 4 steps away from 0. So it has a value of positive 4. So what we're going to do is we're going to see, oh, this is actually going to be negative 4 inside the absolute value right here. Okay, now as we look at these two numbers, we can say, oh, this absolute value of negative 4, which has a value of 4 because it's 4 steps away from 0, is actually bigger than, or farther to the right, or above 1, which means that it's greater than. So we could compare these two numbers by writing out the statement 1 is less than the absolute value of negative 4. Now it is important for us to go ahead and write it in the form that it was given to us as. Okay, so this, well, these two statements are going to be similar. Okay, we're not going to be giving this one. That's a no-no. Okay, we're going to be giving our numbers in the form that we were asked. Okay, so we can see here that 1 is less than the absolute value of -4. Okay, so again, if we're going to be comparing values, we're going to be comparing -9, or the absolute value of -9, and 7. So we know that -9 is right here. Okay, but we also know that this is the absolute value of -9. So the absolute value of -9 is going to be equal to +9. So when we do the absolute value of -9, it's actually all the way up here. Okay. Then as we're putting 7 on our number line, we're going to see, okay, well, here is +7. So we have our statement now. Okay. And we can say now for certain that we have 7 is less than the absolute value of -9. Now we're going to go ahead and work these out on your own. So go ahead and pause the video here, find the answers to 5, 6, 7, and 8 on your own. And then when you're done with that, push play so we can go ahead and work these out together. Now as we look at the absolute value of -2 and -1, we need to figure out which one of these is bigger. Okay, and we're going to be using these less than, greater than, or equal to signs inside of these yellow boxes. So as we look at the absolute value of -2, well, the absolute value of -2 is actually equal to +2. And we know 2 is going to be more than -1. So we're going to put in here the greater than sign. Now, if you have trouble remember that, we can always think, okay, there's my alligator mouth, and it's always going to be eating the bigger one. So we're going to always have that open to the bigger one. It's going to be turned away from the smaller one. Here we have -7 and absolute value of 6. Well, absolute value of 6 is equal to 6, and 6 is bigger than -7. Even though 7 seems like it's a bigger number, okay, it's actually lower than 6 on that number line. So it's less than. So we're going to put in that less than sign. As we look at the absolute value of 10, we can see the absolute value of 10 is just +10, and +10 is going to be less than 11, because you'd rather have $11 than you would want 10. So we'd say that this is less than. Now as we look at this, this is 9, and this is the absolute value of -9. Well, we know the absolute value of -9 is actually going to be equal to 9, which means that it's going to be equal to that same value. Now, for example number 4, we're going to be talking about a real-life example. So we're going to be taking some of these concepts and applying them into a situation where they could show up. Now, in science, we can talk about the freezing points of different liquids. Okay, the freezing point is the temperature at which a liquid becomes a solid. Now, we have here listed a bunch of different freezing points for different liquids. Okay, and we can figure out which one of those, by comparing those numbers, has the lowest freezing point. So as we put butter onto our number line down here, we can see, okay, butter has a freezing point of 35 degrees Celsius. Airplane fuel has a -53. Honey has a -3. Mercury has a -39. Candle wax has a 55. So just by putting these onto our number line, we can figure out which one has the lowest freezing point, because we just go to the left, because the farther to the left we go, the lower the temperature is. So we can see that airplane fuel has the lowest freezing point. Now for part B of this, we're going to be looking at the freezing point of mercury or butter and seeing which one of those is closer to the freezing point of water at 0 degrees. So if we look at mercury, we see that that's -39 degrees. If we look at butter, that's 35 degrees. So which one of those is closer to 0? Well, here is 0, and we already have a way of figuring out that number, because the absolute value tells us the distance from 0. So the absolute value of -39 is equal to 39. and the absolute value of 35 is equal to 35. So we can see that mercury is 39 away from 0 and butter is 35 away from 0, which means that butter is closer to the freezing point of water, which is 35 degrees Celsius. As an extra example here, we can talk about comparing seawater freezing at -2 degrees Celsius and which is the closer to the freezing point, honey or seawater to the freezing point of water. Now as we look at this, we remember that honey has a -3 degree freezing point. So we'd say, okay, honey would freeze at -3 degrees Celsius. So we'd say absolute value of -3 is equal to +3. And we would say, okay, absolute value of -2 for seawater is equal to 2, and 2 is closer to 0 than 3 is, so we can say that seawater has a freezing point closer to normal water than honey. Now, this is one I want you to try on your own. So, is the freezing point of airplane fuel or candle wax closer to the freezing point of water? And explain your reasoning. So go ahead and pause the video here, and then once you are done figuring out which one is closer to the freezing point of water, go ahead and push play to check your answer. Now, the freezing point of airplane fuel is going to be at -53 degrees. To figure out how far away that is from the freezing point of water, which is 0 degrees Celsius, we're going to be plugging that into an absolute value equation. So the absolute value of -53 is equal to 53. Okay. Now we're going to be comparing that to candle wax. Now candle wax has a freezing point at 55 degrees. Okay. So if we're plugging that into our absolute value sign, we can see that that's equal to 55. Now we need to ask ourselves which one of these is closer to 0, the freezing point of water. Well, 53 is going to be closer to the freezing point of water than 55. So we can say that the airplane fuel has a freezing point closer to water than candle wax. Okay, so as we're looking at this, we're finding the absolute value of the integer. So the absolute value of 6 is going to be equal to 6. The absolute value of -13 is going to be equal to 13. The absolute value of -17 is going to be equal to 17. And the absolute value of 0 is equal to 0. Okay. Now you deposit $125 in your checking account. 1 month later, you withdraw $65. Write each amount as an integer. So if we are going to deposit $125 into your checking account, okay, we're going to be increasing the amount in that account. So it's going to be a positive 125. Okay. 1 month later, as you withdraw $65, you're going to be taking out $65. So you're going to be minusing $65. So it would be -65 as an integer.